YouTube and stuff. Today
We're
I won't
live.
do all that.
We went through a lot.
Okay, I'm going to stop my share for 1 second and just reshare again.
Hello, Luis. Hello, everyone. Welcome to today's Lunch and Learn. A great topic on how to secure your Agentic RAG chat box with REM Labs and ApertureDB. We're going to give everyone a few minutes to join. And while we are waiting, I was reading something about, we're in the season of state fairs this starting now. And I was reading that there's a food thing that people go to state fairs to like have these specialty foods and different foods. So I'm curious, if you do go to state fairs, what is your favorite food? Like, they're interesting ones, but I thought that was an interesting read.
Now that you mention, I will have to go to figure out what my favorite food is.
I think I really like those funnel cakes, as they're called.
Oh, interesting.
Yeah.
What's interesting is that I think you're like the second person who like mentioned that, Saurabh.
Yeah.
Yeah, someone was talking to someone. They're like, the pancake waffle thing is what they is what they call it.
I think it's one
So
of those places where you can sort of, let yourself go a little bit. So,
okay, so Luis loves hot dogs. There's some like really interesting combination, and some state fairs are even known to have specialty foods like garlic dip pickles and just very interesting
Wow.
combination of things. So I thought that was really interesting. They're like, I think Minnesota State Fair, they're known for their bunt cakes or something. So like different state fairs are known for different things. So we're gonna get started in a minute. I'm gonna sneeze.
So, have you tried California State Fair? Now I have to go.
Yes, they're different ones, and they're very, very different from each other, and there are lots of them. So that's the one thing, and it's both a combination of interesting vendors. There's a whole animal part, with 4-H1 Club, and you see, rabbits and people who won and different things, and then of course there's entertainment and rides and things like that. So it's kind of an interesting experience, actually. All right. So we're going to go ahead and jump right in. Once again, welcome to our Lunch and Learn today. And it's all about how to secure your Agentic RAG chat box with Realm Labs and ApertureDB. My name is Denise Moxie, and I'm the Director of Product Marketing at ApertureData. And I will be your host for today's Lunch and Learn. But before we get started, hold on for a quick second. My PowerPoint has decided that it doesn't want to work, so we'll try it again. Really? So, really what we're going to look at today are really three things. And they are, first, I'll give you some housekeeping details. Next, of course, we'll jump right into the topic of securing our Agentic RAG. And then finally, we'll wrap up with some Q&A. For housekeeping, I really, really want this to be an interactive session. So feel free to jump in. Cream puffs. Jump in. Feel free to jump in, ask any questions. I will sort of get on the stage and help facilitate your questions throughout the presentation. As always, a complete replay of this Lunch and Learn will be available at the end. And that's pretty much all on the housekeeping side of things. And so now I'd like to go ahead and do a quick introduction of our topic today. So as many of you know, your chat box may be leaking data. And the question always comes up around, as we more and more enterprises begin to use chatbots, there's also a question around security. Like, how are you ensuring that the security of the data and who is accessing and receiving information is authorized to do so? And that's precisely what we're going to jump into today with Saurabh Shintre, founder of Real Labs, and Vishakha Gupta, also founder from ApertureData. They're going to together, they're going to give you a deep dive, a look at how to secure your agentic RAG solutions using both their technologies, REM Labs and ApertureDB. And so let's get started.
All right, it's my turn.
Yes.
All right, perfect. So yeah, good morning, everyone. I'm assuming it's morning wherever you are. It's morning for me. Let me just give a quick introduction for who Realm Labs is. Probably you guys are more familiar with what ApertureDB or ApertureData does. So let's see if we can move it. Yeah, Realm Labs is a complete platform for securing all kinds of AI applications, whether it's information that's going outside to applications you don't want to go, or if you're building applications of your own, how do you make sure that you have the right guardrails, you have the right role-based access control and data security around all of these applications that you're building. Increasingly, we are also seeing a lot of enterprise use cases coming up around agents. So we also have some solutions that let you connect to these data sources or tools through MCP servers in a very secure and authorized way. So basically, anytime you're thinking of AI applications and you are concerned about security, either because you are an enterprise that's consuming this kind of an application and you're worried about your own data, or you're building for the enterprise and they're asking you a lot of questions around data security and they're slowing you down, you can come think of us, come talk to us. We'll probably be able to help you out. We have an incredible team of folks who have been doing this for a long time, and we have done this at a very large scale in our previous gigs at security companies, but also big tech giants and so on. So with that intro out of the way, I just want to sort of get really deep into this immediately. So fun thing is that because I'm doing a talk now with ApertureData, I think I don't have to spend a lot of time on this particular slide. Everyone here should probably know something about Retrieval-Augmented Generation. But just to be sort of respectful for anybody who might not know this, the idea behind RAG is essentially that you don't put all of your data into the model itself. You create embeddings, you chunk it, you create embeddings. And when the user's question is, or when the user asks a query, you basically first go to the vector store and try to find out what context is relevant for that particular query based on embedding similarity. And then you take that context along with the query, and then you pass it on to the model to come up with the response, right? So that's essentially what RAG does. And ApertureData and ApertureDB and many other companies like that are trying to build or have built very good solutions around how do you store these embeddings and so on. But there are other aspects of building a RAG, especially for the enterprise, particularly around security. That is one of the areas where we have found gap, and we are trying to sort of provide a solution there. And today, what we are going to talk about is what are some special advantages that Realm brings you and also Aperture brings you that allows you to build these kinds of applications very, very fast, very robustly, and pretty easily. So RAGs are ideal for enterprise applications. The number one, advantage is that your data does not go out to Sam Altman. It stays within your organization. Only the information that is relevant to the user query is sent as part of the context of the query, but nearly all of your data stays within your organization or wherever your VectorDB might be hosted. Given that it's also independent from the model, it's not been used to fine-tune the model. Updating that data is inexpensive and can be done very easily. As all of you know, enterprise data keeps on changing all the time. This is not answers like, okay, what is the capital of the United States? That doesn't change in every 200 years. This data is changing constantly, so you need to be able to update it pretty quickly. Secondly, in enterprise chatbots, a lot of the use cases are around getting factual information, right? You want to know what happened to this particular project. You want to know what your revenue is and so on. So when you have a RAG architecture, it's much more easier for you to ground those facts into real documents, reducing hallucinations, something, you can't afford to have massive hallucinations in the case of enterprise RAGs. So this is sort of what makes RAGs very, very interesting and ideal for enterprise applications. Of course, now you are seeing, a little bit moving away from the traditional RAGs into agentic RAGs and so on, but the principles still apply. And that's why there's a lot of interest in building enterprise RAG applications, agentic applications, and chatbots. Most of you would be, oh, I see a question slide. Okay. Yeah, feel free to ask me any question. Denise, please feel free to stop me if there are any questions here. So you've seen, solutions like Glean, solutions like Microsoft Copilot, which are getting very popular in the enterprise. But RBAC, as we call in security, which stands for role-based access control, remains a challenge. So even though all of your data is internally stored, it's still not enough in the case of enterprise, because enterprise data has very strict access control on who can see what information. So not all information is available to every user. This is something you know if you work in an organization. Unfortunately, most of these RAG applications that are being built across the enterprise require admin credentials. So if you are working with Copilot, it has access to all of your data. Working with Glean, it has access to all of your data. So, if you're trying to build a RAG for all of your users, you might also want to work with admin credentials. And in that case, you are the one who is responsible for making sure that only the data that is shown to a user is the data that they can see, right? So it's not something that the user login process will help you with. You already have access to all of it, and you have to basically make sure that you have this role-based access control. The other challenge that makes RBAC very complicated is that permissions within enterprises are incredibly complex, and especially when you look at diverse data sets, like Microsoft has its own permissioning and authorization system, Google may have its own, and these are very complicated structures that are very hard for people to unpack, especially if you are from an ML background. Most of your background is in building ML applications and evals and stuff like that. You may not necessarily have the right background to understand how the permissioning and everything else is working. And all of these basically lead to the fact that RAGs, when created over enterprise data, can leak very sensitive information to an unauthorized user very, very easily. This is not a hypothetical concern. I think Mark Benioff said this about Microsoft Copilot a long time ago, that it is leaking other people's emails to the wrong person. You can find your CEO's email, personal information, and all those other kinds of things. When we go and talk to our customers, we hear this concern all the time that, whether it's Copilot, whether it's Glean, whether any other application which is even self-built, you always have these issues that you come across. So building secure RAGs are not as easy as one may think, right? So there are multiple reasons for that, but we're going to go into them one by one. So ultimately, what question you want to answer is that, okay, when the user asks a query and a certain chunk is pulled from a particular document, you want to answer the question that, does this user have access to this document? So let's say somehow you had access to all of this information. Let's say you knew that this particular user has access to all of this document. You've done your work, you've scraped all these permissions, and now you're trying to build a RAG. How would you go about this, right? So there are multiple ways in which you can implement these permissions in your RAG and ApertureDB. And again, the goal that we have here is to make sure that users can only see what they're supposed to. So the first and the easiest one that you can do is pre-filtering, which is that you are going to take all that information of who can access what. You're going to only, for each user, you're going to create a completely separate vector database only with the documents that user has access to. So you are going, if you have 10,000 users, you're going to have 10,000 different vector database. As the user logs in, you go to the right vector database and you do your search over there. So advantage of this approach, highly secure, highly accurate, right? So again, there's no mixing of data from different users. It's incredibly accurate because you are in that vector DB accessing all the information that the user has access to. So in that case, the results that you're going to get are going to be the best quality results. The downsides are essentially that this is extremely inefficient, right? Because if you have 10,000, 100,000 users, maintaining all of these vector databases and everything else and orchestrating them is incredibly complicated. And the second one is not adaptable. Every single time a content changes, you have to go and find all the vector DBs in which that content was present, update all of that. All that synchronization is just way too complicated. In very small teams, and I've heard from companies with like 200, 300, 100,000 users, you can get away with pre-filtering. But as your number of users increase, as your number of files increase, which in the case of a large enterprise could be hundreds of millions of files and tens of thousands of users, this is not going to scale. The other approach, which is more popular, is post-filtering, where you build one vector database for all the users. And then once you pull that chunk out for a particular query, then you go and verify whether this user actually has access to this file or not. If they don't have access to that particular chunk, then you drop that chunk from the context and only forward the chunks that the user has access to the model. So again, incredibly efficient because you're only maintaining one vector database for all users. Highly adaptable. Every single time a permission needs to change, document content needs to change, you know what you're doing and where you have to go. The downside is that all of the data for all of the users are mixed into one DB. So in that case, any kind of misconfiguration could, right? So it has slightly lower security than pre-filtering. And it's also low accuracy because in many cases, for a particular query, the kind of information that you might pull in may not be accessible to the user at all, but there might be some other documents that the user would have had access to, but they just never got pulled in because that's how vector database or vector search works. So you might end up losing all the relevant context and giving a user no answer, even though the user may have had answers from some other documents. So it does reduce accuracy of your search results a little bit. One of the best ways of doing this would have been to actually just work with the vector databases. So most vector databases support some kind of metadata filtering, right? So they allow, you can have like tags and other kind of simple metadata, and you can do your query subject to certain metadata filtering conditions. So ideally, it would have been very nice. It would have been secure, efficient, accurate, and everything else. But the problem is that most vector databases, ApertureDB not included, do not support metadata of the type that is feasible for putting in access control information. So it's very good for putting tags like, okay, is this movie a comedy movie or a horror movie and so on. But when you're looking at an access control information, again, you are looking at thousands of users and you have to sort of store this binary, metadata for each user, whether that user actually has access to that file or not. And therefore, it does not scale really for real world use cases in the scale in which you have to operate in the enterprise. And I'm going to show you guys a demo as well a little bit. So building secure RAGs, as I said, not as easy as one may think. A big challenge is that when you are answering this question, which I asked before, that does this user have access to this document? It actually is multiple questions in one question, right? So firstly, does this user have a direct access to the document? So is the user being granted direct access to the document that you can understand? The other question of this is that does this user have access to any folder that might contain this document? Another one that you need to check is that is this user part of any group that has access to this document? And then, as you can imagine, it gets complex. Is this user part of a group that has access to a folder that contains this document? So it's a very complicated sort of graph representation of how permissions really work, right? So this is not a static information or binary question, it's a graph. And unfortunately, large parts of that graph are not even present in one place. So when you connect with the data source, you obviously would understand the content, you would have understanding of the file hierarchy, and you might have access, or you might also understand the access control list, which might say that this document is accessible to a particular group. But then you also need to connect with the identity provider often, which is something that you may not even think of doing. And the identity provider is the one that's going to give you information about, who is the user, how do their group memberships or domain memberships actually look like. So the access control list will tell you that this file has access to this group, but then the identity provider will tell you that all these users actually are part of this group. So you need to connect to these different things to be able to get a complete picture of which user actually has access to which file. Very complicated graphs that keep on updating. In many cases, the group membership might change, which does not reflect at all at the document level, but that still has implications on whether the user has access to this or not, right? So all of these things basically play a huge role in unpacking this information. This is what Realm helps you do. I'm going to show you a quick demo, but essentially, the reason why we are here with Aperture is because Aperture's graph search is essentially an incredibly powerful tool for storing this kind of information, and that at runtime, being able to figure out whether the user has access to this file by looking at sort of how you can do this graph traversal and whether this user in some sense is connected to that particular file in Aperture's graph search as well. So that's sort of where we are right now. I'm going to show you a quick demo of how sort of Realm allows you to, or how a permission RAG should look like. And again, it's live demo, so bear with me. You can see my chatbot, right? So yeah, so here we have a chatbot basically, and we have a bunch of profiles which are, finance, HR, and so on. So let me first sort of log in as a user, which is finance. So I should be able to ask questions and get answers to questions like, okay, what is our revenue for Q4. And hopefully the RAG will be kind to give me the answer. Okay, there you go. So yeah, I do get the answer for this. I can go and take a look at this. Okay, what was the file that was used? And this was a file on Box. The file permission was okay, which means finance actually does have access to this file. And then some other content checks that we do also pass through. But if you ask the same question, for example, and you become the HR user, and if you ask the same question, then hopefully you should not get any answer. And again, I've logged in as a different user. And again, AI is not going to give any answer because the file that we're being used to pull this particular, the chunk that was being used to answer this query, the HR user doesn't have access to this, right? So in that case, again, you are able to remove this particular chunk. Similarly, if I ask questions about HR-related things, like, okay, did we have, and I think I'm still logged in as a HR user. So if I ask questions like, did we have any incidents of harassment in our company? Let's see if RAG is kind enough. Yeah, so it will give you the answer from, let me give you a second. And yeah, it particularly pulls this document about investigation. Again, HR user does have access to this. But again, if you're going to go and log out and log in as finance user, ask this question, we should not be able to get the answer because, again, this document that contains this information, which is a report investigation, is not accessible to the finance user. So being able to build this kind of a capability in your internal chatbots or whatever you're doing for your customers is incredibly important. And this is where we are able to help you connect to those documents, extract those permissions, but ApertureDB is what helps you sort of store those permission graphs in a very compact way so that you can actually, at the time of query, you can find out whether this particular chunk should be used or not. So I'll hand it over now to Vishakha, and she will explain to you how all of this works behind the scenes. And I'll stop sharing my screen.
Thank you, Saurabh. That was a very good summary, and pretty much I don't have to say much, but I will give an overview of what ApertureDB is and show an example of how it can work behind the scenes from the actual storage and search side. So I think all of you heard in the importance of securing the responses that go out, and whether you are just building a simple question answering bot for testing, or you are using that logic and starting to plug it behind agents to help them answer questions. This fundamental problem remains important to go into production. So what we essentially heard from Saurabh are some key requirements to make something like this happen. It's essentially the permissions are graph structure. You need semantic search, of course, because that's where you are finding the documents you're looking for. And then you ultimately actually need to access the documents because that's where you're pulling information from. You might need, beyond just answering questions, you might need to share that data with the users who are interacting with the chatbot. So essentially, those are the three key pieces that we realize for this technology. And your options. So Saurabh alluded to the fact that there are vector databases in the market. A lot of them allow some sort of filtering, but when you realize that your permission structures are graph-like and more complicated, which means you have to tape together a graph database that can help you represent those permissions with the vector database for semantic search and the data management for actually accessing the data. And while it might seem like, well, it's quick to install, but they all speak different languages, and you have to make sure that you can coordinate the data as you are accessing. So you carry the IDs around all these different databases. So you can spend days or sometimes months making it work, optimizing it, making it consistent, or use something that's purpose-built for such requirements. So that's where ApertureDB comes in. It's a data layer for AI teams to centralize different modalities of data, and it offers a unified interface to find that data by semantics, by context, or by both. So it's a graph vector hybrid database purpose-built for multimodal AI, which makes it really relevant for implementing the sort of use cases we are talking about, because essentially Semantics is a vector search. Context, in this case, we are talking about is permissions, and how to filter the responses by that. And in fact, it could be any other business logic for that matter. But in this particular scenario, it's the permissions. And then because the data is actually being managed by ApertureDB, within the same call, you can actually access it. So just to kind of give a quick overview of how we make that happen, there are some key components that help us accomplish all of these things, right? So there is a data layer, so you can actually store documents, images, any of the other information that you are retrieving. So tools like Realm Labs, for example, will help you get data out of your legacy systems along with the permissions. You'll store the data itself and let ApertureDB manage it, and it's a cloud agnostic data layer. It allows high throughput access, and it makes it very easy to even pre-process certain modalities of data, right, as you are using it. Then the second key component is a memory-optimized property graph database to store the metadata, and you can construct knowledge graph with application information, but it certainly makes a really good substrate to represent your graph permissions. And then the third component here is a multimodal vector database, which can help you find things by similarity. And then, of course, we don't want users to have to talk to multiple systems, and we want them to do, to get what they need in the format they need by doing one query to one database, which is why that unifying query engine comes into picture, and it makes sure it coordinates the queries across different components, and then the responses are funneled through from the same system, and it basically ensures that you get transaction guarantees across whatever modalities you're dealing with. So if you're building these applications, instead of having the users or agents talk to 3, 4, 5 different data tools to accomplish one task, you essentially make one call to ApertureDB. So now, the important thing is, how do you actually make it happen? So let me show you the various things that you need to do in order to make that happen. Give me 1 second. All right. So the first thing is setting up ApertureDB. It's a database, so you kind of have to decide where you want it to be running. The easiest option is to go. We have ApertureDB on our cloud. It's a self-serve. But you also do have these other options to set your own instance, and we can help you with it. But let's take the simplest example. You go to, you can sign up on cloud.aperturedata.io/signup. It'll allow you, you'll essentially have access to a 30-day free trial when you start. I already have my instance created. I have multiple instances running. I can very easily go and introduce a new instance by just choosing the name and the provider. So let's say we go over and look at what's running in this instance. So so ApertureDB comes with a web interface to allow you to look at the data easily. So the first thing I want to talk to you about is the graph itself. So what I did, and let me come here to show you. I hope you can see my screen. I'm going to increase the size a little bit. All right. So what I did here to kind of represent the example that Saurabh was showing you, right? Hopefully you can see it. So to represent the example that Saurabh was showing, we took a small example to make the demo easy to explain and stuff. We took a small example with like 9 documents. They are all PDF files. They have certain sensitivity. And these documents, and there are basically users in the system. So kind of what he was showing you with the demo on how do you switch from the HR and finance. So there are users, and these users belong to the groups. And I'm showing you the CSV format just because it makes it easy to understand what is going on. So now, one of the ways to represent permission is like essentially what we are saying is the file is accessible by certain groups. Okay, so this is what I ingested in my instance of ApertureDB. So this instance, you can see it shows blob, user, group. I'll come to the descriptor and descriptor set after. But as you can see, there is this relation between blob and group, which is accessible, and there is also a property on the edge. So to back up a little bit, I mentioned how ApertureDB has this memory optimized property graph database that it supports. So essentially, this dashboard is showing you all the different nodes or objects that are in the database now and how they are connected or related to each other. So that's what we are seeing here. Each of the, so the user, for example, when I ingested this information, as you can see, the users have first name, last name, email. When I ingested, you see the email, first name, last name, the string, and I have it indexed on the email property. There are different ways in which you can ingest data. We are creating, we have been launching a lot of different ways to ingest data into ApertureDB, data ingestion from S3, ingestion from, some known data sets, and there's going to be like a lot of new things coming up soon on our cloud. So you will be able to very easily just specify your standard format files and ingest the data. For now, the method I chose was to use our ADB command line tool, and that just specifies you have a CSV file like I showed you, and you can just ingest blobs, you can ingest entities, which is basically your application level information that you want to ingest, and then you can connect them together. So essentially with this, I created all this information that you see. Now, let's see if we can see what's in the database, right? So I want to see all the groups that are present in the database. So as we can see, there is finance, there's HR, there's all. You can also just change to say, well, I want to see all the users. And so you see all the different users that are present in the system. It makes it really easy. Now, I have introduced those text, the documents that I showed you in the CSV file. So let's say I want to see all the documents where the sensitivity is public. So right now, we are essentially what I'm showing you is the ability to filter just by metadata. We haven't done semantic search yet. We're just looking at, all the information that you could store from the application standpoint. How do you use that to your advantage to navigate all the different data there is? So as you can see, blob, we have documents that can be represented as blobs. So essentially, this shows you the name, the sensitivity, and we filtered it for public sensitivity. So you can see all this information just from the UI without, without leaving this. So now let's come to what I did in terms of supporting. So once that's ingested, now we want to essentially embed the document, because that's the next step towards building your RAG pipeline. So this is all helper functions and the code. We'll share the code when we send out a summary of today's presentation. So what I'm essentially doing is just using LangChain and OpenAI models to first read the PDF files that I have, and I do create indexes in ApertureDB for certain, to speed up certain accesses. But essentially, what I am doing is creating the embeddings, and I am connecting embeddings with the document. So if we come back to our interface, embeddings in ApertureDB query language, they are called descriptors, and they belong in a descriptor set, which is your search space or collection of descriptors. So you will introduce a descriptor set, you'll add the descriptors, and what we also do, so you have the descriptor set that contains all these descriptors, but your blob, the document you added, can also be connected to that descriptor. And this is important. We'll come to the value of that later. So essentially, I did the usual, ingest the embed the document, store the embeddings in Aperture, and also connect. I connect the corresponding blob to the corresponding embedding. And you could have multiple embeddings. You could split the document into different paragraphs and have per paragraph embedding. The choice is completely yours. ApertureDB will allow you to do that very easily. And now, essentially, this is very simple code. I'm just doing that for all the documents. So this is the ingestion completed. So now, wrong Now, if I go, how do I query this information? So essentially, I'm using my ApertureDB key. I'm using my OpenAI key, just connecting to ApertureDB instance. So this is what's behind the scene. This is what can be behind the scene to what Saurabh was showing you on the graphical interface. I'm showing you the implementation side of how you accomplish those queries. So you essentially these are just helper functions on generating embedding for the query. But what's interesting for this purpose is how I figure out my allowed documents. So I do a k-near neighbor search. This is my semantic search. So I get a user query, I convert it to an embedding, and I find my near neighbors. But I also see which one of those is allowed in the group. So I get a group name here, and this is a very simple version. You can make it more complex. You can traverse the hierarchy. But here I'm just filtering it by, I want to make sure the documents that I return match the k-near neighbor query. Remember, we connected the document to the embedding. So that's how we can go to the document. And we also have the document connected to the group. So between the two of them, what I'm saying is I want documents that are connected to both. So this, and you can find the details in our documentation, this parameter allows you to combine and get a node in the graph that is linked to the two other searches that you just did. And that's how we essentially do the queries. So now, sorry, I ran this beforehand because the vector generation was taking some time, and I didn't want to hold off. So the question I asked here, what's the salary of David Chen? It's an HR permitted question, so HR can see it, but finance should not. This is just doing regular vector search, right? So if you do not apply any permission and you just did vector search, this is the answer you get. David Chen's salary as senior product manager is $145,000 per year. Now, when you apply correct permissions, HR is allowed to see it. As you can see, the user here is HR. You can see the same answer. Their base salary is $145,000. However, when I change the group to finance, so the finance group is asking this question, which would mean they don't find any corresponding document, and so we get the response, not enough data to answer the question. So this kind of corresponds to, when Saurabh showed you switching the group of the user, when he did those queries, essentially in the background, this is how you could execute it with the semantic search and with combining the information that's in the graph about the users and groups. And while this is like, one level check on just the group, you could essentially make it a lot more, complex, traverse it there. You could create edges from documents to the right users beforehand, filter it by owners. There's a lot that you can do to make this happen here. So that's essentially, what ApertureDB can allow you to do. We did the setup, ingest data, navigate in the UI. You can enrich with embeddings. But of course, people ask like, hey, how do I just make that ingestion simple? How do I make embedding generation, graph generation simple? So that's what brings me to just kind of quickly introduce this concept of workflows, where we have been templatizing commonly run tasks. So, make it easy to ingest, make it easy to generate embedding. So you're just pointing and clicking on that cloud interface that we saw. And these workflows can be one-off or run continuously. So for a chatbot, for example, you could essentially give it the documents and run the workflow. It'll generate the embeddings. It'll make them ready to be queried by a RAG chatbot. And you can use them on cloud. You have them available on the GitHub repository here, and you have Docker files to run them locally. And we have a rapidly growing collection of workflows to make things even easier for anyone using ApertureDB. So in fact, the very next thing you'll be hearing from us in the coming weeks is 12 new workflows, and we would, love to get your feedback as we go along. Now, one quick thing I want to talk. So Saurabh, towards the end of his presentation, talked about the importance of permission, of scale and performance. So we've been working with enterprises with large amount of data, and just from the productivity standpoint. So there are various metrics on which people evaluate data tools. One of the big metrics is how does it help the teams? even before you get to scale and performance? Is it simplifying their lives? So we've seen, teams using Aperture have seen 10 times productivity boost. And you can imagine, when you don't have to deal with Frankenstein data solutions, when you have one place to query information, one place to keep it consistent, it certainly has an impact on AI teams, data engineering teams, to make their lives a lot simpler and then let them focus primarily on AI innovation. We've also tested ApertureDB on billion scale graphs so far, and we continue to scale it up. But we were able to accomplish ingestion of 65,000 nodes per second and a lookup of 15 milliseconds in a billion scale graph. So one of the important things when Saurabh mentioned the millions of documents in large companies and a lot of permissions, the performance of the graph and the ability to scale becomes really critical. And then, of course, we have also done performance comparisons against popular vector databases, DIY combinations that people have to create because of disparate tool support, and we can be anywhere between 2 to 35 times faster. Particularly compared to popular vector databases, ApertureDB vector search runs 2 to 10 times faster, giving you sub 10 millisecond search times. We are integrated with a lot of different tools, so you can create your applications easily. And essentially, it's one-stop database for you to create a lot of different AI applications. And if you go on aperturedata.io/resources, you'll see a lot of the blogs, including the one we wrote together with Realm Labs, and it links to examples for you to try on yourself when you sign up on ApertureDB Cloud. This is where I'll stop now and hand over to Denise.
I just wanted to make a couple of points more, if that's okay.
Actually, before you begin, I wanted to thank both Saurabh and Vishakha for a very insightful presentation on our Lunch and Learn. We do have a question, actually, so I'd like to, it comes from Rohit, and he asks, I see how Aperture can filter queries by an attribute to implement access controls, and how Realm might be mapping external permissions in queryable attributes. Are there other ACL-aware operators?
Sorry, I'm not sure if I understood the question.
So it seems like he's asking, he understands how Aperture can filter queries by an attribute to implement access controls, and he's interested in understanding, are there other ACL that aware operators?
Yeah, so I mean, from an application perspective, what we're showing here is also relevant for agents, right? So even when you have agents, you have to make sure that they're operating on behalf of certain access and authorization decisions that are being made of what they can and cannot do. And I'm sure that I think Aperture graph search is also going to be useful in sort of those kind of operations, if I understood that question correctly. But in case I didn't, Vishakha, that might be for you.
So I wanted to give a little bit more clarification.
Yeah.
So he clarified that he meant, is there more to the integration between the two companies' products?
Oh, got it. Yeah. Okay. Yeah. So yes, there is. So as Vishakha rightly said, we are very good at understanding permissions, connecting to data sources, connecting to identity providers to unpack all of this. And you can basically use us and ApertureDB so that once you give us the credentials, we are going to put all the data and all the permissions directly into a vector DB, which is ApertureDB, right? So you won't have to do anything at all. It will just be a couple of click solution, and that's going to create a vector DB entirely for you. That's ready, and it's hosted by Aperture, so that whenever you are making the query to ApertureDB, you are always going to get the permission response back, and you won't have to do anything. So directly from us, we consume the data, put it directly on ApertureDB. You don't have to go and sort of, you could, but you don't have to do this I would say, putting all of these things together. They are integrated.
And just to add a little bit more, I think to Rohit's question in terms of, is it just ACL? Are there other things that you can filter based on? Yeah. So the graph part, you can extend it to, essentially introduce any sort of attributes that you care about filtering on. And just like I showed you in the query, you'll be able to put more conditions before you return the response. So just within that same query, when you do the semantic search, if let's say you want to, if you were tracking IP address and there was a range that was allowed, that would be one of the allowed range would be one of the things that's presented and or that's stored in the graph, and you filter it based on that.
Yeah, and there's also other signals that we also capture. So we don't just access the ACL metadata, any metadata that's associated with the document, whether it's, certain specific labels. So enterprises have a lot of labels associated with these documents, last updated, who is the owner, all those kind of things. So you can put all of that information into ApertureDB, and then you can use that as filter conditions.
So I'll wait for a quick second while everyone gathers their thought regarding questions at this moment. But I do have, as I work and talk with customers, we actually have some discussions about what's required to secure their RAG chat box. And so I'd like to sort of begin a discussion. So Sonam asks, what are some of the challenging customer use cases you have seen with this integration?
Saurabh, you want to start?
Yeah, sure. Yeah, so I think we already, support a couple of customers who have built, these kinds of like permission chatbots, particularly for SharePoint, which is a very common and horrible data source which nobody likes to actually go to. So we work with a couple of companies that build chatbots for their customers and the data resides in SharePoint. And I think for the most part, we have been able to successfully kind of launch with them. They've been using Realm and these integrations now for almost 6 months without any downtime, actually, which was very surprising. But some of the early days did have some challenges. So, again, SharePoint is a complicated beast. Even Microsoft doesn't fully understand how it works. And there's always some new things that sort of, new metadata, new APIs, new information, new types of documents. So building that coverage, for example, for us took us a lot of time. And I think that's where once we were able to build it, we were actually able to solve for our customers this problem and save them almost like a quarter worth of development time. And they just had to focus entirely on, which embeddings to use, how to sort of do evals and all those kind of things. The entire aspect of data connectivity and vector DB creation was completely taken care and taken away from them.
Yeah, and for us, that translates, primarily into are we able to help them scale and run the k-near neighbor searches fast, combine that with the permission filtering fast. So while we don't necessarily have to deal directly with, all the different tools that you guys have to integrate with, for us, it comes more on the side of like the querying and can we simplify how they generate these embeddings and stuff, which is where the workflows come into picture. So I think between the two solutions, it's easy to kind of handle the primary challenges that people face in productionizing these sort of use cases. Yeah.
I think, and also this integration is what makes life much more simpler. So the other alternative to this, which is post filtering, where you first do the vector search, then you take those chunks and check whether those chunks are actually accessible to the user or not. Oftentimes what happens is that while you're writing code, some of your developers might forget to do this permission check at some particular instance, right? In that case, you start leaking. So it's always best that your vector DB itself returns information in a way that is permissioned, and which is what is possible with this integration. So you don't have to make like 2 API calls and always remember to like run all of these API calls in the correct order and so on. This integration takes care of that problem at all, completely from you.
So one of the questions that often come up when we deal with security is, for a lot of users, many can understand having access restrictions to the entire document. But how about just portions of the document? Is it possible to do that as well?
Yeah, it is possible to do that, but that has to happen more on the content level. And that was one of those other things that I want to show, but maybe we don't have the time. But in many cases, there are parts of the document which are not particularly sensitive, and you could use them, even though the whole document is sensitive. And in many cases, the whole document may not be sensitive, but certain parts of it might be sensitive. So then it comes down to our content filtering capabilities. So Realm also has this ability to find sensitive content So as soon as we consume the data and create a chunk, we'll also be able to tell, hey, is this particular chunk contains something sensitive, whether it's PII, whether it's, any kind of company confidential information. And at that point in time, we can always give you a signal that user does seem to have access to this particular document, but this document is, or this chunk seems to be sensitive, and maybe something that it should not be used for creation, even though the user might have underlying permissions on it. Oftentimes, this becomes very important because certain types of permissions in the company are very complicated. Most companies have notoriously bad permissioning systems, and there is a stat that almost 90% of permissions that are granted are used only once, the first time they were granted. They were never seen or used after that. So there's a lot of proliferation of excessive access in the companies, and in that case, the solution or the problem that you're talking about comes across all the time, and then we can deal with it at the content level.
Yeah, and to add to that in terms of representation, I think so. The example showed a simple case of just embedding the entire document and storing that, but you could have essentially the document node in the graph connected to its individual paragraphs and the embeddings associated with the paragraphs or whatever your segmentation is. And when you do those, when you do the semantic search, it matches on the certain paragraphs, you can decide whether that particular thing is what has some restrictions or not. So it's up to the application and the users to make at least the graph and the semantic search side as advanced as they want to support those level restrictions or permissions.
Yeah, and along with permissions, we also sort of scan the content. And again, these are labels that we like, what you saw in the example that Vishakha showed, whether it's confidential, whether it's sensitive. So typically data security has 4 levels in any organization: public, internal only, confidential, and restricted. And we can basically scan the content to basically tell you what we think should be the sensitivity label. And again, this is another metadata that you can then ingest in ApertureDB at the time of the creation of the graph. And then you can search that, okay, I only want to see documents that this user can access, but also documents that are not confidential or not restricted. And then again, VectorDB will be able to, or Aperture will be able to give you the right documents for that.
Thank you for that. Quick question. So we're hearing a lot about AI agents. That seems to be sort of the new buzzword. So curious to understand, how does this technology or integration affect that landscape?
I can take that. So again, this is where I think what we have been talking about becomes even more important, because if you look at agentic actions, they are themselves graph in some sense, right? That you first go and make a particular tool use case. Based on the result that you get from that particular tool call, you're going to go and proceed with another tool call and so on. So all of these actions themselves become graphs. And then again, ApertureDB would be a perfect place to sort of store all of these graph representations. And along that path, what Realm will do essentially is again figuring out what part of those graphs are not accessible to a certain user or a certain agent, right? So when a particular action is not allowed, and we'll just be able to basically tell you that, hey, this part is not connected anymore to this user and or this agent, and then it's not going to proceed. So it becomes even more powerful with agents, this particular representation.
Yeah, like Saurabh said, it's not just the fact that essentially, if you look at agent memory representation too, so there is the task calling and then the memory representation. You have both. You do semantic search, you do context-based searches, you combine those two. So this combination becomes that much more important. And given that there is a lot of agents now suddenly have access and they can start taking actions, making sure that you restrict at the right places and introduce those permissions and what's allowed, what's not allowed in their query path. Like Saurabh mentioned, it's that much more important to do, and that too at scale and high performance.
So Sonam asks again, do you see a huge demand for agentic RAG solutions?
That's one of those depends kind of questions, isn't it? There's a lot of demand, and what we are making sure is that those evaluations can actually turn into real production deployments, because once you get into the real world deployments, that's when No one wants to compromise on their security, privacy. No one wants to compromise and make their users wait for a long time. And they want relevant responses instead of, hallucinated responses and stuff. So this becomes even more important. And we are essentially trying to cater to the demand and make sure it stays and grows. Saurabh, any thoughts?
From our perspective, incredible demand. I would maybe highlight you that Box just published their State of AI report, I think yesterday or this week or something. Go take a look at that. They'll highlight exactly what we are talking about. What kind of applications do they see being enabled because of these agentic applications? What are the security considerations? What are the usability considerations, and so on, right? And the demand from users is incredible. There are so many manual tasks that we spend a lot of our time on, and I think Vishakha and I can probably sort of feel that pain the most. That we just want to sort of get taken care of, right? We don't want to deal with those tasks, and we just want to sort of automate them. But just giving some random agent all of my Google email permission or even my banking information or something so that it can do whatever it wants is something I'm not okay with. So this sort of a problem, the user demand is high, but security, privacy considerations, usability considerations are slowing it down. And if we are able to find a good solution like what we showed you today, you can speed up getting to that beautiful world, by almost like a quarter or two.
And Rohit has sort of a follow-up question about agents, and it's really about scaling. So he indicates that there are perhaps 4 broad tiers of information access: public to confidential. But there's also hundreds of individual actions that agents need individual permissions for, and he cites that Amazon has over 20,000 K alone. So the question of the day is, any scaling tips?
Yeah, not the easiest of things, to be honest with you. I think it has to be. We have sort of done these kinds of analysis for a lot of the popular tools like calendar, email, your box, and other kind of things. It depends a lot on tool. If you look at something like AWS, there are so many permissions that you can configure. All that Wiz did and became a $30 billion company was trying to fix those permission configurations, right? It's not an easy thing to do, but I always say that start small. And just make sure that you have very, very, very good understanding of what your application is trying to do. A lot of these, we have seen, at least from my perspective, when you try to build like a universal agent on day one, like we saw, there was a company, I would not name them. They were essentially a browser-based agent that you could do whatever you wanted on the browser. And it made so many mistakes, it made so many errors, and did so many harmful things. And you would imagine that, when you have such a powerful tool, but still powered by a technology that has fundamental weaknesses, you're going to go and have bad things happen to you. So it's not a good answer, but reducing the scale might be a good place to start with. Just have a very focused and narrow definition of what you want to achieve, and then see whether you can do that with the highest standards, and then sort of scale rather than trying to build something upside down from day one.
And the thing that I would add to what Saurabh is saying is how you structure your data and how you represent it starts mattering. I mean, it's very easy to say, well, I know this tool. Let me just take MySQL or any other like graph database and try to store this thing. I will do the combination. It's small enough, manageable enough. But then as you start growing, these things come to bite you later. And then it becomes too hard to kind of migrate everything and you're stuck in it. So even when you're starting with a smaller data set, if you choose something that can scale, so of course, ApertureDB is one of those cases where you can, and you can build it for that scale going forward. So you take the example like Saurabh is saying, make sure everything works, choose the right tools for your application, and then if you set everything right, you should be able to scale. And then we are here to analyze if something is not scaling to help you.
Okay. So that brings us to the end of our Lunch and Learn today. Thank you both, Vishakha and Saurabh, for this insightful session. And for the attendees, thank you for spending a part of your day with us. And hopefully, our Lunch and Learn about how to secure your RAG chatbots with ApertureDB and Realm Labs have helped you kickstart and jumpstart your journey on building your own RAG chatbots. And of course, we're both here. We're always here to help. You can you will receive at the end, you'll receive a copy of today's replay as well as resources and also how to reach out to us both at ApertureData.io as well as remlabs.ai. Thank you and have an awesome rest of your day.
Thank you. Thanks, Saurabh. Thanks, Denise.
You're welcome.
Bye.